My name is Ben. In today's tutorial, I'm going to show you two ways to doing the exact same question. And you decide for yourself which is the preferred method. And let's say this question is actually a paper 1 question. What then would be your choice? Would either use a calculator, which would be the preferred method. Now bear it in mind, and I'll see you later. Bye. My name is Ben. In this tutorial, I want to highlight to you that there are times that is a clear winner. That means the most efficient method for that particular kind of question. Of course, all the methods, even guess and check, is mathematically sound. But you wouldn't want to waste so much time using the guess and check whereby you have another method. So indirectly, a lot of us, we have really filtered out certain methods which are so-called inferior. So for the matter, sometimes it is not too accurate in a statement to say that all methods, so long as they are mathematically sound, blah, 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 blah. To me, I feel that you have constraint. What is your greatest constraint? Time. And the other could be the use of calculator, whether is it allowed or not. In paper 1, you don't have calculator. So certain methods may not be so appropriately used when, let's say, you don't have calculator in paper 1. So this is where I'm coming from, and I hope that as teacher, we have every responsibility to actually guide students to look for clues and hints to how about circumvent your constraints, how to go around your constraints. Let's take a look at this question. Motu had $30. If you spend the money on 7 similar pens and 8 similar pencils, he would have 20 cents left. If you spend all the money on 8 such pens and 7 such pencils, he will be short of 20 cents. How much did one pen cost? Of course, you can argue that you can use simultaneous equation method here. I'm perfectly fine with that. But again, as what I said, our constraint is definitely time. You only have that limited amount of time in examination to do your work. And the other is the very fact that there may be no calculator. You cannot use a calculator. So let's try it out with this simultaneous equation method. You have some kind of equations. 7 pens plus 8 pencil. You need $20, 20 cents left, so you need $29.80. And then the other equation, so to speak, would be 8 pens plus 7 pencils. That would be $30.20. Okay, so in this case, you want to, so to speak, get rid of the other variable. Why do you want to get rid of the other variable? Have you thought about that? To me, it is to make them the same so that whatever the difference in the total cost can be attributed to the variable that is kept different. Think in terms of your science experiment. What have you been doing? With regards to all your science experiment, you keep all the other variables the same. Only one variable is allowed to be different. So that whatever the differences in the experiment must be due to the variable that is kept different. Am I right to say that? So this is the very reason why I'm going to make the number of pencils the same. And in this case, you see that they don't have a common factor here. So meaning to say that in order to make it the same, you have to look for the lowest common multiple, which is 56. So in this case, you need to multiply by 7 throughout the whole equation. So to them, 49 pens plus 56 pencil. Okay, as what I said just now, I have the luxury of using calculator. Otherwise, it will be too daunting to actually come about working out the answer to be $208.60. Likewise, for the other equations, I have to multiply by 8 throughout. Okay, so 8 times 6, 64 pens plus 56 pencil is $241.60. So see that these two are the same. So whatever the difference in the total cost must be due to the difference in the number of pens. So 64 minus 49, you would have 15 pens. That will give you $241.60 minus $208.60. You get the $33. Okay, so one pen is $2.20. Okay, so you see the constraint here because it takes a bit of time, and the other is that is on the assumption that I can use a calculator. But in another method later on, I'm going to show you that without calculator, I will get to the question. I'll get to the solution, and I'll get it, I will say, much faster. I'll show you how in the other slide. Okay, see you later. Hello and welcome back. So in this, now I am going to use the grouping method. Why I use grouping method? Because I see beautiful numbers. So what are they? Do you see there's a 7 here, and an 8, and an 8, and a 7. So these two are I would say these are beautiful numbers because you need to recognize this very important clue, because once you identify this clue, you realize that they can be grouped together with an equal number of pens and pencil. And furthermore, with a bit of thinking, a bit of further probing, you will be able to understand or to see how much more expensive is one than the other. At this point in time, I don't want to say which one is more expensive. Probably you want to take the time to think about it, and I'll go through it later on. Okay, let's take a look. Okay, so 7 pens plus 8 pencils. So again, the same thing. 20 cents left, so spend $29.80. So now I'm treating this as a paper one question, no calculator. I'm not going to use that. So 8 pens plus 7 pencil. Again, it gives me $30 and 20 cents. Okay, so what do you see when you add up all together? You see beautiful numbers here. So 15 pens, okay, 7 plus 8, 15, plus 15 pencil. It'll give you the total cost of $29.80 plus $30.20. 8 plus 2, 10. So 80 cents, 20 cents give you $1. Bring up. So you have $60. Am I right? So now, can I group them into one group of 1 pencil and 1 pen? So there will be 15 groups. So 15 groups of this 1 pencil, 1 pen, $60. So one group of 1 pencil and 1 pen will give you 60 divided by 15. Again, you realize beautiful numbers here, $4. So the next thing is to decide, how do I know whether do they cost the same, the difference between a pencil and a pen, or one is more expensive than the other? If there's a price difference, how much more? So let's take a look here. Again, this requires you students to think. So let's say from scenario 1, okay, I have 8 pencil. I want to trade off, I want to exchange for 1 more pen. So what happens is that I will take away 1 pencil, okay? That give me 7, am I right? So correspondingly, there should be an increase of 1 pen, right? So what happened is that you see that if the pen and the pencil, the price of the pen and pencil is the same, there won't be any difference in the total cost. But we see that there's a difference in total cost. Why? Because one is more expensive, and I take out 1 pencil, I put in 1 pen, there's an increase of 40 cents. Do you see that? So $30.20 take away $29.80 is actually a difference of 40 cents. So I can say that, okay, in terms of model, so 1 pen and 1 pencil, okay, will be a difference of 40 cents. And we know the total cost is $4. So since I'm asked to find the cost of one pen, so I would assume that the pens will be the same, draw them equal model. So I plus another 40 cents. So when I add these two up together is $4.40. And divide by 2, beautiful numbers again, easily. 4 divided by 4 divided by 2 to $2.40 divided by 2, $2.20. You see that how without the use of calculator, I am able to solve this question. So this is my bottom line. This is what I'm trying to drive at. You have constraint. Yes, mathematically sound, all methods can be used, even case in checking and listing. But you wouldn't want to waste your time and your effort on this 2 marks question should it ever come out in paper 1. Especially when you don't have calculator, how are you going to use simultaneous equation? So this is where I'm coming from. I hope you understand that I need to bring out to students how to go about identifying clues like that. When you see beautiful numbers here, like what I said just now, 7, the 8, and 7, with every decrease that is a corresponding increase, you realize they add up to both to be the same in terms of total. And then when they have the same number of total number of pens and pencils, you can group them together. So this is what I'm trying to say. Learn to recognize beautiful numbers as such. This is very important because, well, like what I said just now, when you have constraint, you have to use this method. That's it. I hope I've made myself clear. Not out to put anyone down, but to put across to a student that you need to recognize when beautiful numbers are presented to you. You need to pick out the clues. Okay, I hope to see you again. Have a nice day. Bye.